Hi, welcome back to Science 1206, the Chemical Reactions Unit. I'm Ms. Ludwell, and in this lesson, we'll talk about neutralization reactions. Let's get started. Neutralization is a type of chemical reaction, it's a double replacement reaction, between an acid and a base that produces a salt and water. A salt is an ionic compound that can be formed during the reaction of an acid and a base. The reaction will look like this. We'll have an acid plus a base as our reactants, and then our products will be salt plus water. A salt does not necessarily mean sodium chloride. In the reaction below, the salt that is produced is potassium iodide. If we go back and look at our reactants, we see we have an acid and a base, produces our salt and water. When we mix an acid with a base, they undergo a reaction where the hydrogen ions, H+ from the acid, combine with the hydroxide ions, OH- from the base, to form water, H2O. An example of a neutralization reaction is HCl, hydrochloric acid, plus NaOH, sodium hydroxide, produces NaCl, sodium chloride, plus H2O, which is water. So we have our acid, the hydrochloric acid, plus our base, the sodium hydroxide, produces our salt, sodium chloride, and water. During a neutralization reaction, the characteristic properties of both the acid and base are lost, and water is formed, which is neutral, with a pH of 7. The pH of the final solution will approach neutral if equal amounts of acid and base react. Neutralization reactions are not just limited to the science lab, they play a role in our everyday lives. Here are a couple of common neutralization reactions you may have encountered. Our first example is antacids and heartburn relief. Have you ever felt a burning sensation after a meal? That's heartburn, often caused by excess stomach acid. Antacids contain bases which neutralize the acid, providing relief from discomfort. Our second example is baking soda used in cooking. Sodium hydrogen carbonate, commonly known as baking soda, is a basic compound found in many kitchens. In baking, when mixed with ingredients like buttermilk or lemon juice, which are acidic, it reacts to form carbon dioxide gas. When heated in the oven, these gas bubbles expand, causing the dough or batter to rise and resulting in fluffy cupcakes and bread. Next, let's look at acid precipitation. Rainwater is actually naturally acidic, with a pH between 5.6 and 5.8. This is due to carbon dioxide gas in the air reacting with water to form carbonic acid. However, the pH of rainwater is often further lowered by human activities that add sulfuric and nitric acids to the environment. This form of pollution, known as acid precipitation, includes any form of precipitation with a pH less than 5.6, including rain, snow, sleet, or hail. The primary causes of acid precipitation are sulfur dioxide, SO2 gas, and nitrogen oxides, NOx, and X represents whatever the subscript might be, gas, released into the atmosphere. These gases, produced primarily from human activities, react with water vapor and other chemicals in the air to form the acidic compounds found in acid precipitation. In this example, we see two smokestacks. One is producing nitrogen dioxide gas and releasing it into the atmosphere. The other smokestack is producing sulfur dioxide gas and releasing it into the air. When the gases are released into the atmosphere, they are reacting with water vapor and producing acidic components. Here we can see acid precipitation falling in the form of rain or snow with sulfuric acid and nitric acid in excess. Significant sources of sulfur dioxide gas and nitrogen oxide gases are the combustion of fossil fuels for electricity generation, various manufacturing processes and industrial activities, and emissions from vehicles. When this acid precipitation is deposited on the Earth's surface, it can cause damage to aquatic ecosystems, forests, fish and wildlife populations, Soils and buildings. Liming, the process of adding calcium carbonate or other base materials to neutralize soils or bodies of water, is a strategy that can be used to neutralize the accumulated acids, helping to restore a neutral pH balance. Liming helps reduce the detrimental impacts of acid deposition, including the recovery of aquatic life in acidified lakes and the improvement of soil quality for agriculture. The soil in Newfoundland and Labrador is naturally acidic, which can hinder plant growth and crop yields. Local farmers utilize neutralization reactions to adjust the pH of the soil and make it optimal for plant growth. They mix a product known as lime into their soil. The chemical name of lime is calcium carbonate, with the formula CaCO3, and it's a solid. Calcium carbonate is a major component of sea, snail, lobster, and crab shells. Calcium carbonate, also known as lime, that is added to the soil reacts with sulfuric acid, commonly found in acid precipitation, according to the equation H2SO4 sulfuric acid plus CaCO3 calcium carbonate or lime gives us calcium sulfate CaSO4 plus H2O water plus CO2 carbon dioxide. These reactions neutralize the acidity in the soil, reducing the harmful effects of sulfuric acid on plant life and other organisms. The result is a more neutral pH level that promotes healthy soil conditions for agriculture. Now it's time to review neutralization. Please complete the learning activities on this topic in Brightspace.